Hello, everyone. Welcome. So my name is Emmanuel Bernard. I work at Red Hat. I'm distinguished engineer. And recently, I've been spending all of my time on Quarkus. So we're going to discuss what it is. And it's got a bit of a pompous tagline, like supersonic, subatomic Java. So let's try and see why we claim those things. So what is Quarkus? Quarkus is it's open source, so you get everything on GitHub, and it's a stack to write Java applications, and specifically Java backend applications. So REST endpoints, connecting to a message-oriented middleware, all of that kind of style of applications. And you can write your good old, monolith with Quarkus, but the team and the framework really focuses on those three things. The first one is cloud native. Who was at my keynote in the morning? Who was not at the keynote this morning? Okay. So cloud native, and by that I really mean an orchestration platform. These days, Kubernetes is sort of the winning platform at this stage, but it's a platform that handles the deployment and the management of your application, keeping the nodes alive, restarting them if they die, scale up, scale down, all of that. It comes with constraints. Ideally, you need to embrace 12-factor applications, do stateless applications and stuff like that. So the framework will help you to do those kind of things. Microservices is about, well, of course, it's cloud native, but also to me, I had this notion of density I was talking about. You're deploying not just one instance, but 20 instances or 50 instances because you've split your application into 50 more. And also the scalability model is going to be different. Also, another thing, key important thing is the communication pattern between one monolith and a fleet of microservices is going to be very different. We did discuss this morning around event-driven, applications and non-blocking message passing. Serverless is a twist on microservices where you really have to start really fast from zero, from a cold start. So that all of that is what Quarkus focuses on. And let's do a demo. And the best way to get started with Quarkus is to well, we could do it from the command line, but here we're going to use code.quarkus.io. So io Quarkus devoxx ms. Who knows and use JAX-RS? Okay. Who knows and use Spring REST? Okay, 50-50. So I'll do both. There you go. So we do have it's not running Spring, but it's a Spring compatibility layer. I'll talk about that a bit later. But otherwise, I need to decide the stack I want. So I want a JAX-RS. I will use JSON, so I'll use JSON-B. I'll use OpenAPI here. I use Hibernate validator to validate my objects. And I want to write a to-do application, so I'll actually persist my to-dos into my application. So I'll use Hibernate ORM, except we're in France, so we'll do it with Panache, and we'll see what that means. And then, yeah, sorry for the YouTubers not listening from France. So I'll use Postgres as my backup database. But you can see a lot of other tech, like around messaging, reactive, cloud focus, observabilities, and so on. Okay, so let's create the app. Yes, let's open this one. So I've got my application here, and I'll copy it there. And from there, I'm here, right? That's the copy I just did. So I go there. I'll cheat a little bit, and I'll copy the front end because we're not going to waste time with me writing content. So it's just copied in the right place on the project. And the next step is to really just get started with Quarkus. And the best way to go about it is to start in dev mode. So let's start Quarkus dev. And what you'll see is that we start the debugger, then we start the stack, and it started, by the way. It took 1 second. That's in dev mode, so it's a bit slower. And then you see a bunch of features that have been installed. Not this one. Yeah. By default, if you go to localhost, you've got a landing page that talk to you about Quarkus. But then we'll see the project as a hello endpoint, which, well, actually, let me start my IDE. Okay, and let me restart Quarkus in dev mode. Okay, so we have the hello resource, which is in this case is here. I can go and edit. So that this one is the JAX-RS one. So I can say hello Voxt. Go there, refresh, and I see the result right away. I keep going. Microservices. Yes, there you go. You're welcome. Okay, I go there, I refresh. Something went wrong. Yes, but it tells me. That's the key thing is that I make mistakes sometimes by accident. This one was on purpose. The key thing is that it gives you the feedback right away. And then, yes, I did forget, in this case, the closing quote. I refresh, and I got the results. So I didn't have to stop, deploy the application, then refresh. What's happening is that I just do code change, refresh, and then I see the results. If we see here, we see that Quarkus has detected file changes, and it will look at those file changes and say, okay, I'm going to recompile. So on a request coming in, it will see file changes, it will recompile, stop Quarkus, restart Quarkus, and then answer your queries. All of that in 0.35 seconds. Okay, so that's how it feels really like a Node.js application where you get the result right away. Okay, but we want to write a to-do app. By the way, this is really changing the way you write applications. It's a very impressive, how much more productive you can be. So that's a to-do app. I've got the front end. I've got no back end, which is REST endpoint. So if I do things here, nothing happens. So we're going to write it. And I'm not much of a Spring guy, so you're going to have to help me on that one. But to-do Spring resource. So I'm going to write a Spring REST controller. Is it request mapping, right, for the path name? So request mapping is where I want it to land. The front end is actually driving that. And then I'm going to have a get mapping, and I'll probably get the list of to-do applications first. To-do actions that I have to do. So public list, to-do, and then get all. Doesn't matter much. The next step is for me to write this to-do file, which is really the Java representation of my JSON structure, right? So public string title, public string URL, public, what else? Boolean, whether the to-do has been completed. And finally, there is a priority order in the to-dos. Because it's a fairly simple application, I will also make it an entity, just like Hibernate entity or JPA entity, right? So I could go there and inject my entity manager and use it. In this case, we'll use something called Panache, so Hibernate with Panache. We've got two modes. One is the repository mode, which is akin to the Spring Data style of things. And we have also something that we call the active record mode, which is not quite true as a definition, but the key point is that the entity itself, the object, and the repository are one and the same object. Okay, so I extend Panache entity, and that's it. Here I can use the regular annotation I'm used to when I use JPA. So in this case, I use Hibernate validator not blank property, and order is a keyword in SQL, so I'll override the column name. Ordering. Okay, and remember, to-do is both the entity and the repository. So if I go back there, I can just get started and do return to-do, and then I've got the list of operations: list, delete, persist, count, stream, all of those. So in my case, I want to return all of the entity, and I'll probably want to sort them by order, by priority. I should be good. Let's refresh. and it tells me it's not working. I don't take a picture with the big red thing. But it tells me right away, okay, you forgot to set up your Hibernate database link. Okay, that's true. Let me cheat a little bit and get that information from here, just to not make typos. So the 4 ones you see are the important ones. The other ones are optional. It's just a better way to develop. So you've got the data source, driver, username, password, and that's it. Hibernate will detect that from your application properties and inject that. So Quarkus is doing all of the glue between the various frameworks. And of course, we're in dev mode, so I'm going to use the drop and create and show the SQL just to be a bit nicer. Okay, that should be better. It refresh, it works, except I don't have data. So I've got some SQL here to import the data, and I'll use, who knows the imported SQL in Hibernate? Okay, you're going to learn something new, which is you can create an imported SQL file. By default, that's the name, but you can override that. And if you put it here, it will be, every time Hibernate starts, it will inject those things. And we're in drop and create mode, so that's interesting. Because it helps to do the rapid development mode. By the way, I didn't restart the app at all, right? Remember that. It's just detect not only the Java changes, but also the resource file changes. Okay, I could go on, doing the update, delete, and so on, but I'll write a search engine, and I could keep going with Spring, but I'll switch to the JAX-RS, the other half of the room. Let me swap that. JAX-RS, so it's going to be vastly different. It's called path. I'll say that I consume media type Jackson, and I'll produce Jackson. Actually, I won't produce much in this one, but and then get mapping becomes get. That's it. It's just the same. So it's really a one-to-one mapping for most of the usage. But here I want to write a search engine, so it's also going to be a get. And I'm going to have a list of to-do. Let's call it search. And I want a word passed, and probably want some sort of pagination. Okay, I'll probably change the path to something specific. So, oops. Search / word / page. And I'll just do the mapping here. Equivalent to the path variable that you get in Spring. So here you got a path param. Call it word, and here path param, calling it page. Okay, and it's where am I here? Yeah, okay, I'm good. So yes, let's say it's a fairly complex. That's your search engine, so it's fairly complex. I'll delegate that to the repository instead of putting it in my controller. So let's do to-do search, word, page, index. Of course, search doesn't exist, but see the autocomplete. Panache is really designed to flow with the auto-completion of your IDE. So here it's like, okay, create the method and be ready. And here I'll use it as a repository. So I can say return list. And I just have to write my JPQL query or HQL query. So this one will return all of the to-dos that are not completed yet. And you might tell me, well, that's not HQL query, that's just a word here. To me, that's HQL query, because it's contextualized HQL query. We're inside to-do, right? So select to-do from to-do where is inferred. And then I say completed equals is inferred here, and then value equals false. I can write here select and do something else, but I don't have to. So in our case, we want to do a search engine. So let's add a new parameter. Let title, parameter number 2. Where is the $sign? Yeah, don't do that. Your DBA will hate you, so careful about that. But I also said I wanted pagination. So instead of directly returning the list, I'll return a query. And I'll do pagination. The best way is to use the page index page size if you're in that specific use case where you just want to pass the pagination, but you can create an actual page object and pass it along the layers if you have more layers and you want to pass the paging information from your web frontend all the way down. And then you can use first page, next page, last page, etc., etc. So in my case, I want the page index, and I'll use a page of size 3, and then list. Could do stream, could do other stuff. And that should be good, except I don't have any UI here. I hope I didn't forget, but if I had enabled OpenAPI, in dev mode, we also enabled Swagger UI. And no, I haven't forgotten, awesome. And then I right away see that. I haven't written the UI because you don't want me to write a UI, but then at least I can give it a try and try it out right away. So if I say first page, Quarkus, there you go. And I've got a problem. Unexpected token, So I made some mistakes in the query. Thank you. So you see, I got the result right away, and with a little bit of help from the audience, I'm recovering quickly. Say again? No, the other one is a like. Yeah. Yay, it's working. And if I go for the last page, I get only one result, so that's the last part of the page. Okay? So that's really, really powerful, really useful. Let me stop that and do, what's the name? Package will create a runner with a library, so you can do layered Docker images like we mentioned in the morning. But here I want to do native image compilation, so I'll go for native. Native. Did I talk to you about tests? Tests are awesome as well with Quarkus. So here I said voxed microservices. Just the fact that I put add Quarkus test is enough for Quarkus to start entirely and then run my test suite. So it's not lazy, it's not a part of my app, it's the whole app that is starting. Because it starts fast, it's all good. So let's see if my test is passing properly. And it's not. Thank you. Looks like there is an extra S missing as well from that one. No, not that one. Yes. No, hold on, I'm lost. This one. Yes. Okay, are we good? Cool. Native compilation will take some time, so let's move on to the slides. Okay, so why did we do Quarkus? See keynote in the morning, right? Remember, we're moving from monolith to microservices, which means a lot more deployments, a lot more instances, so requests per second per megabyte is important. And also, people have less time to work on things, so the platform should be as easy as possible, okay? This one, again, this morning, remember, we enable microservices thanks to the container platform, and that's for the agility at the business level. Now, something we didn't talk in details about is that why is Java a bit at the disadvantage in that universe? Java has been designed for throughputs, requests per second for a given process, and pound it and be extremely efficient about that. They made some trade-offs, just like everybody. They spend a little bit more CPU, they spend more memory to do that. Remember Java, it's an interpreted language. So remember, it's an interpreted language. So you get the bytecode, this is interpreted, and then the hot part are actually compiled down the line by the just-in-time compiler. So it takes a little bit of time to start. And remember, the JDK is a complex piece of code, very advanced, and you're using a ton of frameworks on top of it, like Spring and Hibernate and REST-easy and all of that. So that's another ton, so that's 2 tons, and then your app, right? So that's a lot of classes to load. The second part is that those classes actually take space. Remember the heap size in Java, you say XMX equals 20. First of all, good luck starting a normal application with 20, but otherwise, that's not the whole story. The whole story is the resident set size, the full size of the process in memory, okay? And the heap is actually a part of that. The rest is information about that the JVM needs, including what are the class structure, what's the metadata about it, who is the superclass of which method has been overloaded, which part has to be compiled, so statistics about the usage of a given part of a method, then the actual compiled version of that. All of that is in memory in something called the metaspace. And in a monolith, that metaspace is reasonable compared to the heap size. But if you go for microservices, especially not using too much data like in memory, like your application data, then you see the ratio being very against the heap size. So metaspace is taking a lot of space. And when you compare to other platforms, that becomes a disadvantage, because when you deploy 20 microservices, that it's not a fixed cost, but it looks like it. It's like this certain amount of classes I have to load and maintain is becoming a fixed cost of sort for each microservice, and Java becomes at a disadvantage here. And that's why we've made Quarkus. So Quarkus is 4 things. Developer joy. So that's the live reload, right? Trying to get you to the task as fast as possible and really happy to go and develop. It's not just developer joy. By the way, there is no IDE plugin. I just started Maven Quarkus Dev and then used the IDE you want, even Emacs, believe it or not. We expose APIs that you are aware of. I'll come back to that. But then we unified the configuration. So there is one data source configured. Hibernate knows about it. The connection pool knows about it. They talk to one another. Flyway, which is the database migration, knows about it, and so on and so on. And we use standards when we can, and then we enhance the standard with some ways to do the easy, the very common usage easier. That's what you've seen with Panache, for example. And the native image generation. So anybody has tried to run GraalVM things manually? Okay. Who liked it? Well, Clément. Okay. In practice, so first of all, compilation takes a while, as you've seen. And it's complex. That's the line you need here. And it's missing all of the metadata information. Here we do it right away for you with just one line of Maven or Gradle. And what you've seen in red is the native image. It's a native executable that is running. And every extension we have in Quarkus actually works with GraalVM. Startup time, 43 milliseconds. Memory-wise, this one, 24 meg. Okay, so that's a big advantage. And it's running the regular applications. So let's go to the presentation, sorry. So to my point, the second benefit of Quarkus, it's very small, in memory, very fast to start. If you take the same style of application in a classical cloud-native way and with Quarkus, you will see at least a 2x improvement. That's what we've seen a lot of people, some of our users in production or not. That's the kind of feedback they give us. If you really want for the super tiny memory usage, you go for the native image compilation called ahead of time with GraalVM, and you reach much slower levels. This is not just Hello World REST. This is also for a real-life application with drivers and Hibernate and all of that. You get the same kind of benefits. Startup time is also important. Remember this dynamic orchestration platform? If you screw up a release and want to come back, I've heard people having several minutes to start their application, their cloud-native application. Here we're talking much smaller. And it's also a very important aspect of the dev mode, where you want to deploy things in your Kubernetes or container to do some additional tests, it will save you time. If you go for the ahead of time compilation, then you go to serverless goodness, right? Serverless, you pay by the 100 milliseconds in AWS. So if you take 5 seconds to start, you've paid a lot to do nothing yet, right? So that's a bit of a shame. By the way, this is time to first response, not just startup time. So we don't want frameworks to lazily pretend they've started stuff. The other key aspect is that we've unified imperative and reactive as a platform. So the platform itself underneath is reactive, and then we let you expose either an imperative model, which is easier to reason with and debug with, and the reactive model if you have when you have the need to. And you will very likely have the need to having one thread to handle, all of your requests is a very key aspect for IoT, for example. Like resource-wise, we mentioned the memory usage. That's another memory usage optimization, using a reactive aspect where you got essentially 2 threads per core and not more, and have a controlled memory usage here. We use Vertex underneath, but then we expose that to the Quarkus users. So these are you already have experience with Quarkus. So that's a good part. I saw half of you raise your hand with REST-easy, the other half with Spring, so there you go. Spring is a tiny twist compared to the other ones. The other ones, we actually run those bits. For Spring, we interpret the Spring annotations, and we make them run on the Quarkus native approach, which is REST-easy in our case. So we support Spring dependency injection, the auto-wired and all of that. We support Spring Web, you've seen that example, and then we support Spring Data. So give us feedback, see if it helps you. The idea is we take your knowledge and we port it to Quarkus and you get started. So how does Quarkus work? What's the magic to be faster? We have rewritten it in PHP. No. That being said, PHP is pretty fast to start when you consider that they actually restart everything at each pages, which is blowing my mind. So here is what a framework does in Java. Java does a lot of dynamic introspection. Annotations has been a blessing, but also a curse. We dynamically discover everything. So we parse a config file, say a persistence.xml, beans.xml, application.properties. And all of that, we've got some metadata, which will guide us to find stuff in the class path, like what are the classes that we need access to. The @entity for Hibernate, @autowired for something like Spring, or @inject for CDI compatible engines. And once you have that, you've done your class path scanning, then each class you need to scan them to find the getters, the setters, all of the metadata that each framework needs. Then you compile that into a runtime meta model. In the case of Hibernate, the SQL query that will be used to persist your entity, things like that, right? Then you prepare reflection because you want to do reflection on that method and that field, so you create the method object, the field object, and all of that. Then you create proxies, Hibernate, Spring, all of that. They tend to have a lot of proxy generation happening. All of that is while it's starting, right? And then finally you open your I/O, connect to the database, and you're ready to answer. If you do all of that, except the last point, if you do all of that at build time, and you could if you assume that the application is known when you do the build operation. So it's a closed world assumption where you assume that the application is known when you do the build. All of this parsing, class path scanning, and all of that can actually be done at build time. And while we're at it, we can generate the proxies at build time, and that's called just a subclass, right? And instead of having to generate the proxy, the VM just has to load a class. So what are the benefits? Well, first of all, you do stuff at build time, so every time you start, you already have done that work, so you do the job once. That's good. More surprisingly, it takes less memory. It takes less memory because a lot of classes for the frameworks that I mentioned before and that you've seen on the screen are actually the piece of code that loads and boot and does the class path scanning and prepare everything to be ready and efficient at runtime. It's a lot of code. And that code, since we do the work at build time, we don't have to load it at runtime. That's how you get the 2x memory optimization at the VM level. So less time to start and less memory used. And then we can replace reflection potentially and dynamic proxies to be code generation at build time and up rerun. So from a Quarkus point of view, you do compile your app like Java C style with Maven and Gradle and whatnot. And then we aggregate the frameworks you need. That's a provision phase. And finally, we do all of that build time operation. We call it augmentation. We run, there is a framework that essentially bootstrap the other frameworks at build time. And then you've got the choice. You go and run with the normal JDK you've known your whole life. Or you go for ahead of time compilation, which goes through this compilation phase where you look at the application and instead of using the just-in-time compiler and just optimize the hot path, you will literally compile the whole application. And then you've got a native executable, just like Go, and you deploy that where you want. In this case, that's in a container image. Okay? Same app, you run either on the VM or on AOT. So what's ahead of time compilation? You don't need a just-in-time compiler. You don't need the metadata associated to it, so you save a lot of memory. And you compile everything. The other stuff they do is they do dead code elimination. And that's important because if you look at the VM plus the JDK plus the frameworks plus your app, but your app usually is just a small part app code-wise, then when you look at it, that's a lot to compile and to be put into memory into the native executable. So what they do is they look at the code path, and every code path not used is eliminated. So that's how they squeeze down even more the memory usage. Yes, one drawback of that, so that's great, that's what we want. But one drawback of using GraalVM is that to do reflection, you need to give them the list of classes you want to do reflection on. Because if you could do arbitrary reflection, then any point of your code could be invoked by doing reflection, finding the class by string name, and then loading that specific method. So the dead code elimination would eliminate nothing. So the way they work around that problem is to say, I can do reflection-based call, but you have to give me the list of classes, which is a bit annoying. Well, extremely annoying, actually. But that's the good stuff about Quarkus. Quarkus reasons at the framework level. It reasons at the Hibernate level, at the dependency injection framework level. So if those frameworks know that they want to do reflection on a class, so REST-easy says, hey, the return type is to do, then I need to do reflection on to do Jackson, serialization, for example. We do pass that information to GraalVM. Same for Hibernate. At Entity, we do pass that information to GraalVM. So you as a user, you pass nothing to GraalVM. You just do Maven package -p native, and off you go. We also try and optimize and reduce dependencies as much as we can, and we help the dead code elimination. When we look at a class, an application, and we see that, say, you don't use second level cache for Hibernate, then we can eliminate that extra piece of code. That's even less code to be loaded at startup time, right? So that's the kind of optimization we're doing. So when to use a JVM versus the ahead of time compilation? First of all, if you want density and fast startup time and so on, just use Quarkus. You'll be good, first of all. But if you're focused, beyond that 2x optimization and 2.5 second startup time, what's your next level? Do you want raw performance? In this case, the just-in-time compiler will always be smarter than something that is decided at compile time. The garbage collectors are actually much more advanced. So if you anticipate a rather big heap size, then stay on the JVM. And the other good things, and I don't know if Roberto will mention that in his talk, but a key aspect of the JVM is that you've got known monitoring tools, so your whole infrastructure is ready to monitor a JVM and know when it crashes and when it's working and so on. All of that you got, of course, because you're running on the JVM. And you got the famous compile once run anywhere, so you want to compile on Linux, deploy on Windows for whatever reason, that still works. And finally, you don't have any compatibility issues as far as libraries, because this is just bytecode interpreted by your JVM. Ahead of time compilation, there are a couple of quirks sometimes in some of the libraries that you need to be aware of or verify before you go live with it. But then you get highest memory densities. So if you anticipate kind of a REST style microservice, not consuming that much memory usage as far as heap size, then that's an interesting aspect to really optimize the number of requests per second per megabyte. And of course, for serverless, it's very important because you go from 2 point something second to start and answer the first request to, tens of milliseconds. So that's a big difference. So Quarkus is a framework to start other frameworks at build time instead of startup time. That's a bit weird, but it is what it is. And the way we do the bridge is we don't change the framework up there. We actually do send patches to the drivers and Hibernate and REST-easy and other ones like that. But essentially, the extension is the piece that is actually doing the starting the framework at build time and using the Quarkus infrastructure to do that. So you got a REST-easy bridge. Essentially, an extension is a bridge between Quarkus itself and the REST-easy framework. So at runtime, what you exercise is not Quarkus. This is REST-easy or Vertex or Netty or Hibernate and so on. And then you've got the choice to run on the JDK or to run on GraalVM. And we've got a pretty high, extensive ecosystem. More Quarkus. I did mention test. Add Quarkus test and off you run. So that's pretty good. Very, very useful as well. We've got a nice integration with rest assured. So we inject the right URL, so the port and the name. You don't have to deal with that. I did mention very quickly that Hibernate with Panache could support the active record pattern that you see on your left, but also the repository pattern, which is more the classic DAO style. So you see the two differences. So there is a little bit of extra code that is going on here with the add inject and so on. But that works. It's really a choice on your side. Observability, I don't know if we're going to have time. Yeah, maybe. I'll try and do a demo on health. OpenAPI, Swagger UI, metrics. So Swagger UI, OpenAPI, we've seen that. Metrics is an important aspect of deploying into the cloud, and same for health, to know whether the app is up or not. Flyway for database migration. Kafka, not only via Eclipse microprofile, reactive messaging, which is a nice abstraction for stuff coming in, stuff coming out, in a queue, out to a queue. And Kafka is one of the backend, but you could have AMQ streams, MQTT, and stuff like that. And we also have Kafka streams support with the live reload. So you can change your code and the Kafka streams, the next message coming in will actually go and show the new version of the operation. So that's very useful. Security with GWT is supported. And the Spring compatibility extensions I have shown you. And then you're not limited to the ecosystem we have. You can just get a dependency and get running on the JVM. It's going to work fine. If you want to go for GraalVM, maybe it will not work, so you need to double check that. The good stuff about extension is that it will try and do more stuff at build time and really optimize things more for you instead of doing everything at build time the classic Java ecosystem way. And same for the unification of configuration and so on. Okay. Let me try and do my rest of my demo with health. No, not this one, this one. .quarkus.io. So remember there was a health thing. What's going on here? There you go. Here you can copy a command that I will paste here. And it says, hey, add the extension health. And if I restart my app, oh, okay, sorry, it's done. Localhost health. I do have the database that gives me that information. We anticipate all extensions will offer those kind of things. We have some work to do, but it's going to happen. But I can also, let me auto import here. I can also add some health information. So damn. So another good thing we have is good documentation. Guides, health. And then you see that's MicroProfile, which is offering a pretty awesome, coverage for those kind of things. So liveness, application scope is what I want, and then I implement health check. Okay. Okay. And from there, I can just implement this and return health check response, give it the names. My app is down, and I'm going to add data. And I go and refresh. And boom, I got my result that the database is down. Okay, so that's a super nice way to add health. And monitoring is the same way, more or less. So I'll let you dive into that one by yourself. Remember, developer joy, super good at memory usage and startup time, unifying imperative and reactive. If you want to know more, go to the workshop we have where we dive into that, and best of breed of libraries you already know and use. And thank you very much. We got some time for questions. Thank you. Yeah, we got 4 minutes for questions. Well, you're the first room that don't have questions, so I don't believe that. Yes. Yes, so the question is, what databases do you support? So yeah, in our page, we support H2, Postgres, MariaDB, MySQL. Am I missing something? The DB2 is coming up. Derby is coming up. Yes, Derby is coming up. Oracle is an interesting one. You cannot really contribute to the Oracle driver unless you're sued by their lawyers. So we're having conversation with them. They really want to have that support. I think it's coming. Just give it time for to be mature. But I know they've been working on that, so it's coming. Yes. Which one? Yes, is Gradle supported? Yes, it is also supported. It's not yet in the code.quarkus.io, but it will be very, very soon. The tiny complexity we had with Gradle is the whole add extension is a bit more complex because in Gradle anything goes and you don't necessarily know the structure, so it's a bit harder. But we have a solution that is in place, and we're just going to push and provide that in code.quarkus.io. I'll anticipate something. We do have support for Kotlin and Scala. These are extensions because for Kotlin, for example, we do open classes, for example, which allows you to use the Hibernate things and whatnot. Another question? Yes? So do you provide a way to handle bin validation at build time? So we do start build validation at build time, or more aggressively than the classical bin validation, because we know the list of classes that have constraints, and we do apply them aggressively. In the JVM mode right now, it's actually done at JVM startup time, and in GraalVM there is a bit of a trick, but GraalVM actually pre-start the application, and all of the static blocks are actually initialized. So we do that inside that. So in a GraalVM image, everything has been more started than on the JVM level. That's why also there is a bit of a startup gap. But essentially, more or less to what you're saying, the answer is yes. We don't necessarily generate the code that will do the validation by simplifying the interceptor stack we would use. But yes, stuff are started at build time. Yes. Are you the same guy that asked the question at the Micronaut one, or? Yeah, okay. So the answer is yes. And the reason is we do not use annotation processor. We had some troubles because Hibernate with Panache is doing some magic, and Lombok was like not agreeing with the same kind of magic. But I think this is fixed. This wiring phase here is actually done after compilation. So you do Javac and annotation processor like Lombok, and after that, we actually do build time wiring. So we really read the bytecode, we don't read the Java classes. So that's a technical difference between Micronaut. By the way, Hibernate with Panache, I don't know if you've seen, but I use public fields. You don't have to. If it really offends you, you can do your encapsulation, but it's just waste of time. I mean, how many times have you overridden a getter in practice? You know? So what we do also stuff at build time here. Yeah, this is going to be my last comment. Is you can use here like to-do.order, and if you override and actually override a getter for some reason and override it here, we will rewire it into being a getter. A little bit like Lombok is doing. Not quite, but a little bit like that. Okay? And that's my last answer. Thank you very much for being here and for all of the questions. And I'll stay around. Thank you. Oh, I do have a lot of stickers, so I'm going to lay them here and come and get them.